So last video is actually stop here. Okay, active filter and buffer filter, and low pass filter and high pass filter, and then with a gain. Okay, so last video we talk about all these things. So in this video we talk about minimum components. We are gonna use inverting. Okay, so last video we actually stop here and then states that this is actually non-inverting with minimum components. You can connect in here like this manner. However, there is a problem. So let's discuss what is the problem and why inverting is used at the end. Okay. So if you know that the frequency is large, okay, equals to 1 over 2 pi fc, right? So if your frequency is large, 1 over infinity, because if this is infinity, then everything is infinity also, like, okay, so it will become 0. So in parallel circuit, right, this acts as a open, like, short circuit. So all the whatever voltages will flow through here, right? It will reduce the amount of how do I say, fault. Okay, so if because everything over here is the we'll talk about overall resistance. Okay, overall resistance. So if the lower your frequency is better, because you amplify your gain, right? The lower frequency will be better in this case. Why do we say so? Right? Because as the lower frequency, you will know that it will become, as this frequency becomes 0.00001. Okay, lower frequency, right? So you're divided by 0.001, you'll have a very big number, maybe like infinity lah, right? So in this case, infinity parallel with your resistors R2, right? You're gonna have a very high impedance over here, right? Maybe um high impedance, infinity lah, okay? So in this case, you know that this thing divided by R1 will have a gain, right? So the higher this is, the more gain you have. So the lower frequency you have, the higher gain you can have, right? This is the trend that it is lah, right? So this also corresponds to the low pass filter. As you can see, this is low pass, right? This is low pass. So low pass filter, if you remember this, what is it? This is the frequency, this is the voltage. So it starts to go down, right? So as your frequency, if your frequency is low, okay, if your frequency is low, your gain is actually this big, right? So if your frequency is high, you're gonna decrease. As your frequency increases, your gain is gonna decrease. So this is exactly what the hell it's doing lah. Right? As the frequency increases, okay, maybe I should change a different color. Everything's red, very, yeah. If this is increases, if the frequency increases, the overall circuit will actually become 0, right? If you remember, if 1 over infinity equals to 0 right? If your frequency is like that big, so you'll be like only R2 in this case. So in this case, the so-called the gain itself is the least of it, that thing. So this is exactly the how it works for the low pass. In this case, right, your R2, okay, your R2, and in fact, right, this shouldn't be R2. This should be Z equivalent, right? Because it is equivalent to the R2 and the capacitor. So in order to be more clearer lah. So if your R2 is damn small, right, let's say 0.01, maybe 1 ohm lah, and then your R1 is like 10 ohm. So you will have a because you know that if your frequency increase, okay, if your frequency increase, 2 pi fc is equals to 1 over infinity, right? Because frequency is infinity, equals to 0, right? So if 0, the overall impedance is 0 plus the resistance 1 ohm. So you only have 1 ohm over here. So overall, the Z equivalent is like 1 ohm divided by 10 ohm. You will have 0.1 ohm. I mean 0.1, okay, 0.1 plus 1, 1.1. right? So this also explains why your gain can never have a less than 1, because you'll always have plus 1. This is a non-inverting amplifier, right? So you only can amplify to a larger gain. You cannot amplify to a lower gain, right? So our wanted frequencies are not reduced, but our wanted frequencies are amplified. Okay, so what do you mean? So our wanted frequencies, let's say this is the frequency, this is the mode, right? So if you know that this is a low pass filter, right? So the other frequencies are all the high frequencies, right? So they are not reduced, they are just filtered out only. And then the other frequencies are all amplified, right? Whatever that is, like, before the cutoff frequency. So yeah, before, so these are all the sections. So this is the cutoff frequency. So whatever thing that is before the cutoff frequency is all like so-called being amplified. Nonetheless, there will be some frequencies that are being amplified like after the cutoff frequency, but it's less significant in certain sense. So yeah. So in this case, why? Okay, my fault. I explained wrongly again. Damn it. So um, let's say you have a frequency, you have a voltage, low pass. Okay. In this sense, you may say that this is your unwanted frequencies because they are all high frequency, right? However, if you were to do this amplifying thing, you're gonna amplify all the unwanted frequencies also. Right? So if you were to amplify all the other frequencies, in this case, um, I also don't know why. So if you were to, because if you were to amplify all the unwanted frequencies, it's also a wasteful because you don't want your unwanted frequency also. So if you were to amplify all these other frequencies, yeah, it is not very efficient. So you want most of the gain to amplify your wanted frequencies, so you have a more gain. So in this case, non-inverting amplifier cannot do that. Okay, if you were to ask me why, for example, if you want to so if you have a certain frequency, right? If you have a certain frequency that is within these wanted frequencies, you allow the voltage to tap in, and then you allow this gain to take place, so you have a higher voltage over here, right? So if you have a unwanted frequencies that is over here, right, you typically you don't want any voltage to come in anymore, you don't want anything to flow in, so you don't want to waste your voltage or what. So this is the reason why non-inverting cannot do that, because if it's non-inverting, a frequency, if it flows, if you put it inside the op amp itself, it will in any case, because any frequency can be allowed, right? Any frequency can be allowed and then can be amplified also. So because there is a, I think you know what I mean already lah. So this is the key issue. So what they actually do is actually to use an inverting amplifier. So what is it about? So we can use an inverting amplifier with frequency dependent gain. Okay. So frequency dependent gain. So I get it. The keyword is actually frequency dependent. Okay, this non-inverting is not frequency independent. Why? Is because of the one. Okay, of the one gain. Because any frequency, in this case, you still have a gain of one. Okay, although you didn't amplify, because no matter how, no whatever, if you remember whatever frequencies, right? Where do I start? You have a very high frequency, right? So if you have a low frequency, okay, let me repeat again. So if you have a low frequency, okay, in this case you have a low frequency, your overall impedance reactance will be very high, right? Over here in this case, if you remember, if your frequency is low, 1 divided by 0.00, you will have 1 over infinity. I mean infinity lah. Okay, you have, let's say this R2 is 1 ohm, right? 1 ohm, and then plus your infinity ohm, right? So in overall your Z equivalent will be infinity divided by 10 ohm. You have a very large voltage gain, which is reflects over here. So if your frequency is damn low, you can actually have a very high frequency. High voltage gain. However, if your frequency is very high in this case, right? Your frequency is damn high, you only reflects 1 ohm, which is the R2 only. So R2 divided by R1, you have, so it depends on the R2 and the R1 ratio. And however, you always have plus 1 in this case. So you always have a voltage. So the signal is always, because as you can see, maybe in a graphical way, you have a graphical like this, right? So in a high frequency, in a low frequency, you want to, because you want to amplify this scenario, right? You're gonna amplify all this, right? You're gonna amplify all these things, right? However, if you have a very high frequency, okay, you still have a signal over here. It's not a very good example. For example, this is the normal voltage. Maybe you put in a 1 volt, okay? So if you're 1 volt and you have a very high frequency, if you have a very low frequency, you're gonna allow amplifying of the low frequency. You're gonna have a, meaning if this is like low frequency, right? You can actually amplify your signals. Right, you can actually amplify your signal over here, which is what this low pass filter is doing, right? Low pass amplifying filter. So if your frequency is high, okay, let's say if your frequency is high in this case, you still have a signal over here, right? But the purpose of this thing is to, the purpose of low pass is actually to prevent any unwanted signals, right? So with this phenomenon, you are still allowing the high frequency to flow in, right? You are still allowing the high frequency to flow in, so you are not filtering out any high frequency at all. The high frequency is still there in a sense, right? So in this case, if you so objectively, right, you would want at high frequency, you want flat out 0 volt. So as your frequency decreases, then you can have maybe a higher frequency, a higher signal, and as it becomes more and more lower, you will have more and more amplified systems, right? So this is the low pass system that is trying to do. So in this case, the non-inverting amplifier cannot do that, right? So yeah, I don't want to repeat again. So inverting wise, it can do that. Inverting wise, because the formula itself doesn't have a plus 1 anymore. So it's purely affected only by the impedance over here, right? And this impedance is mainly due to the capacitance, right? One frequency equals to 1 over 2 pi fc. So this is the thing, right? So if your frequency increases, and then you have a 1 over infinity is equals to 0. So you have a so this is like this is still a low pass filter, right? So in this case, right, if you remember, the low pass filter is actually like this, right? So if your frequency is damn high at this point, right, you have a 0 volt. So R2 divided by R1. So it's purely mainly on the ratio between R2 and R1 only, right? So if R2 is, let's say, 1 ohm and R1 is like 10 ohm, you have a very small output voltage, small output gain. Small output gain, okay. So 0.01 times your voltage, yeah. So in this case, you have a flat out, maybe a lot more lousier. So you actually felt all the high frequency. So as your low frequency, so as your capacitor become lower, as your frequency become lower, you actually amplify. As you can see, if your frequency is lower, okay, this is lower frequency, right? Your voltage is very high, so you're gonna increase. The reason why the voltage is high is because you actually increase the impedance. So you're gonna you're gonna amplify the signal. So this is actually what it wants in the overall scenario case. Right, this is a very key concept for low pass lah, inverting low pass. So what is the key difference between this inverting and the non-inverting portion over here? Right, maybe I should clean it up. Hold on. So if I were to where is it? If I were to bring this one, okay, low pass with buffer and gain minimal components, right? If I were to bring this down, the difference is what? The difference is only V in. If I put the V in over here, and then I put the ground over here, it's exactly the same thing as this, right? So it's just where I put my V in only. Okay, so I put my V in the non-inverting side. The problem comes in because of the plus one gain. You're not gonna filter out the high frequency at all. You're not. So in order to filter out all the high frequency, you're gonna use the inverting signal. Okay. So this is why it is in this case. So you may want ask me, what if it's a high pass filter? This is actually a low pass filter, right? What if it's a high pass filter? Then you just simply change to inductor, that's all. Right? Because now XL is equals to 2 pi FL, right? So if the frequency increases, your overall impedance will increase, right? Plus your R2. So this is like impedance equivalent. So this is like infinity, right? So infinity plus this is also infinity, so you have a very high, this is okay, so you have a very high frequency, you have a very high gain, right? So this is what it is lah. So low frequency, then you have only R2 divided by R1, and the things goes on. So this is the key difference. So this is the reason why you need to use inverting rather than non-inverting in this case, with minimum components. Okay, if it's minimum components, you can actually use this system. Okay, this is for low pass. Okay, with capacitor. High pass, you're gonna change to inductor, right? And then yeah, hold on. So I think I have explained fairly bit. Hopefully it's clear for buffer filters with gain minimal components. Okay, if you want a very little components, okay, if you want minimum components, mainly is frequency dependent. Okay, frequency dependent gain. Okay, so you're gonna use this configuration. If you just want simple amplifier with buffer, you can just use this one. That's all. Right. So yeah, I'll leave you to think about it. Alright. So yeah. So bye bye. See you next video.